Should be live. Hello, hello. As you're joining in, and say hello in the chat. We're going to wait a couple minutes here. So now I'm a minute early already as well. Oops. Some old artifact in my slide. How's everyone doing today as well? Again, if you want to say hello in the chat and where you're watching from, that's always fun. And then also, if you want to include what you're working on, even better. If you're building agents, have you tried a code mode agent before? Are you working with MCP? Always kind of fun to hear about what people are doing in the field. Oh, and while we're kind of waiting, actually, a couple things. Let me bring them up real quick. Again, as you're joining in, say hello. I'm just going to pull up a couple things I forgot to pull up that might be relevant to you. So 2 things is, if you're in Seattle, which is where I'm streaming from, by the way, I have a couple upcoming events that you might be interested in. One is tomorrow, actually. We are hosting an event in our office with Voxel 51. They're a really cool tool around computer vision evaluation type of stuff. So a little bit different than agents, but if you're still interested in that space as well, that should be really fun. And then also the week after, we just posted, we're going to do a hack night on building agents and agentic loops. So if you want to join either of those, you should do so. Hopefully it'll be pretty fun. I think the agent hack night kind of thing is going to be fun. We're going to use Flight 2 DevBox and for that. So, or even the local stuff potentially. I guess I haven't come up with all the actual rules, but the idea is going to be building agents on Flight, which you'll see a little bit of today. But this isn't going to be strictly code mode agents, although I think we could do that as part of the event. So if that's interesting, go check those out. And again, I'm going to wait another minute. I see people are rolling in. So again, as you're joining, say hello in the chat. And again, if you want to share anything that you're working on, that definitely makes it way more fun for me. And I think for other people as well. But today we're going to build a code mode agent that's going to do some data analysis for us. And I kind of have a multi-step thing that we're going to run through for the code. So most of this is going to be code. You have a few intro slides just on some concepts and to kind of go through as people are joining. If you want to run the code, I'll share this link. So actually, I forgot to put the collab button inside of the main README here. So again, as people are joining in, I'll just kind of go over this briefly. So normally, if you've come to some of my workshops in the past, I like to add people to a union cluster that you can kind of run this very easily from. But if you were here last week, I had a problem with our kind of demo cluster for adding people to. So I wasn't able to do that today. The next one I should be able to do it again for sure. But because the last time that happened and people were saying how they really wish they could have still kind of run some code. The cool thing about like using Union or Flight, which is what we're building this on, which I'll go more into that later, but Flight's an open source AI runtime. So you could actually run all the stuff that we're going to do today locally as well. So if you did want to take some time and actually set up a dev box, you could do so. It should be very quick if you already have something like UV installed. But I know when I do virtual workshops, a lot of people don't want to go through the extra setup step and they want to run things through Colab. So normally I add you to a cluster and you can run it. Because that wasn't able to, I wasn't able to add people to our kind of demo cluster today. What you can do is still run this notebook, and you're going to be able to run all of the code but it's going to run just purely in the notebook environment. So it won't go to the cluster. You'll see what that kind of looks like. I'm going to show my end of that, and that allows me to kind of like scale out and fan out to all this compute, and you get a better kind of UI for all of your run versioning and artifact versioning, but you used to actually still get a lot of that locally. It just isn't surfaced the same way. So you still actually get caching. There is a way to do some versioning locally. We won't look at that today, but we'll get like caching and retries. So you get some of that kind of the durability aspects of running tasks and agents with Flight just purely locally in the notebook today. And I apologize that I couldn't add people to the cluster again today, but you'll be able to run this and actually come away again with kind of a code mode agent. You just won't have, like here's an example of a run that we're going to do. You just won't have access to this cluster that can fan out and run all these things like in parallel. Yours will be running sequentially inside the notebook, but it's written to when you connect to a flight cluster. So if you did set up a flight cluster later, you can fan all these out in parallel as well. And you'll see, I guess, spoiler alert, this is the code mode agent we're going to write. We're going to see that when we compare the sequential agent here, this is the number of turns it did versus the code mode agent. We'll talk a little bit about this in the slides here in a second as we get going. But the idea of writing code mode agents is that they can be more efficient. It's not all the time, but that's kind of like the idea stemmed from that. Originally came out of Cloudflare, I believe. At least they used the term code mode first from what I know of. I'm sure other people kind of did similar things. But we'll go through the slides and talk a little bit about code mode. And we can dive deeper into some other links if people want. But we're going to build something that, again, for our use case today is much more efficient with the code mode thing. And we're going to run the code execution inside of a sandbox that's built on top of Monty. I'll talk a little bit about that as well. But so it runs the code securely, so it's not going to like blow up your cluster or anything like that. All things you have to think about when you're doing code execution from agents. So again, I'll show those links again as we go through and actually get to the running part, but just wanted to set it up that you will be able to run code. It's just going to live in Colab and still use flight and actually some really cool local flight features, but I'll just show the cluster on my end today. All right, so are people ready? I see a lot more people joined in. I shared a link to Slack as well if you want to stay connected outside of the workshop. If you have any questions later, you maybe want access to the cluster to try something out for your company. I could definitely add one-off people, and I just can bulk add people from the workshop today. All right. So we're going to build code mode agents. And again, our use case is going to do data analysis. We'll actually get a chat interface. And it's going to query data and actually be able to generate charts and answers based on what we query it. And just a tiny bit about me. My name is Sage Elliott. I work at Union. I'm an AI engineer there. And I'm in Seattle right now, streaming from here. But I go to San Francisco quite a bit too. Looking to do some stuff down there next month in August. So also keep an eye out. We're probably going to do an agent hack night down there, probably late August. So I haven't posted yet. If you have venue ideas, let me know. I have some that I think I can host at, but I'm always looking for other ones. And then also a lot of people know me right now for running an AI book club, where we've been reading like a new book every month, and it's been really fun. If you want to connect with me on LinkedIn, keep up with any of those things, you can find me here, or just search Sage Elliott. It should be the one that pops up. And again, just a call to action. You don't have to do this, but if you want to join the Slack channel, talk about all those things like the books, a lot of other ML projects in our Slack community. I think we're almost like 6,000 people in there right now. And then obviously, of course, anything about Flight, which is our open source AI runtime that allows you to scale out your compute reliably and run both agents or any other kind of AI workflow task durably. We'll see some of that in action today, but you also get everything snapshot in version. So every time you go to a run, if I go look at, this, these are all versions of me running the agent today, and I can click into any of these and go see exactly what happened. Like this is my agent fanning out, and I can click in and I get a history of what happened in there. So everything's versioned. You also get retries and infrastructure awareness. So we'll see in Flight, you actually define compute just in your Python SDK as well as Docker images. So something I haven't seen a lot of other tools give you is kind of this infrastructure aware piece. I'll talk about on the Flight side. Sorry, I'm getting ahead of myself. All right, so code mode. Who has built a code mode agent before in the chat? The chat's a little quiet so far. I do see someone saying, well done, quite interesting and informative. I haven't said too much yet, so hopefully, I mean, it's interesting already. That's good. So again, the idea of code mode is that instead of passing tools to kind of a somewhat maybe, I don't know if normal agent is the right word, but what people are usually how they're defining agents is you have your LLM, you're going to pass it a set of tools or something like an MCP server, and it's going to go ahead and usually kind of run those tools sequentially. Again, there's ways where you could fan this out in different ways, like if you build an efficient planner agent and stuff like that, there's definitely ways that you can make this somewhat more efficient depending on how it's set up. But in general, you're basically giving it like instructions, a set of tools, and then it's running that, like it's running a tool, waiting for a response from that tool to get data, seeing the response, and then, you know, going on to the next tool or making some other planning step. Whereas a code mode agent, what you do is you can pass it tools, but within, it should be within a sandbox because you're executing code. And then it creates a like program, usually in Python. But there's different, I assume you can do it different ways. I've mostly seen this in Python. LLMs are really good at writing Python. So you can pass it tools and say, hey, here's like pre-existing function or tools. Instead of you sequentially figuring out to, you know, run this tool, get data, and then do something again, do another step with it. You can do that probably all at once with Python code. So it could write, you know, do this query, and then after that query, I don't have to really think about it. I know the next step I want to do, and it can basically write a whole bunch of Python functions or Python things to do all those steps at once, based on the data. It doesn't have to like get the results and then pass it forward. So that's kind of the idea of code mode, is that potentially, again, not all the time, is that it can be really more efficient than writing kind of these regular agents. Does that make sense to anyone? We'll kind of see this in action a little bit later. So if it doesn't make sense now, hopefully it makes sense later. You can also Google code mode. There's a lot of stuff on it, but hopefully that kind of comes across a little bit here, where you're writing code instead of writing kind of steps in plain text, if that makes sense. And then you can just run those probably all at once, as long as kind of your step allows for it, or your query kind of allows for it. And Doug asked, can we replay this later on YouTube? They have to drop partway through. Yep. So at the same link that you're streaming from right now, whether you're watching on YouTube or LinkedIn, the recording is going to be there. And the links are in the description too. So if you're coming back to this, you can click the links below. Monty. So I was going to add an image here. I didn't link this either. So Monty is a minimal secure Python interpreter, and it's created by Pydantic. So it basically, I just copied this from their GitHub here, which we can look up, and I should share it. I will share it in the chat. So Monty is a Python interpreter built in Rust that is made by Pydantic, and it allows you to run code safely. So it doesn't have the normal like input output, doesn't have network access, anything like that. But it can write code to call functions or call tools and then kind of pass that data. But it can't write code that can basically do anything like malicious. So here, completely block access to host environments, runs a reasonable subset of Python. So again, it doesn't have everything. This is just again, this is for your agent to express its way of thinking and how it wants to organize like tool execution. But this isn't writing just pure Python that can execute anything. Like if you're running Claude Code and you're telling it to write Python locally, that can actually execute Python scripts to go do things and searches and stuff like that. This is basically allowing it to write a subset of Python that is safe to execute and not going to hopefully do anything malicious here. So a small set of standard library. It could do OS or some stuff with the OS system, typing async. These kind of things are built in. Like it says, it cannot do the rest of the standard library, use third-party libraries, so it can like pip install things in, define classes. It looks like they're looking to potentially add that later. But the idea here is that, again, you're going to pass it like a set of functions. Like in our case, we're building this kind of analysis agent, and we're going to have some things that it can do, like it can query, it can create a metric, it can create a chart, it can create tables, describe columns. These are all kind of pre-built functions that we give it. So you can think of these are tools that it can call, but it gets to organize the code and then run those and execute. So organizing it instead of doing it in kind of the English tokens or natural language tokens and JSON. I'm gonna open up a can of LaCroix here real quick. Somebody asked, would running Monty on top of a runtime control plane like OpenShell or Flight over engineering or good practice? So it can be a good practice. And we're actually going to use Monty today. So Flight actually has a built-in sandbox. So we actually have several sandbox versions. We have this one called workflow sandboxing in Flights. And this allows us to write or use the sandbox and execute code in there. And this is built on top of Monty. So that's why I'm talking about Monty here. But when we use the code today, it's actually calling this sandbox from Flight. So you don't have to install or set up Monty separately. It's already kind of built in. But if you're not using Flight, the concept is all here, and you can go install Monty and kind of build your own sandbox in this way if you didn't want to use Flight for whatever reason. And since I'm already in the docs here for the, and I think the next slide goes into anyway, for the agent piece, we're going to build a built-in Flight native agent. But again, this concept all transfers over to if you're just building agents in pure Python. Also, if you're using Flight or Union for agents already, or you're looking to use them, you can do it just in pure Python. You can use the Flight native agents, which we just have some basic agents in here that does like the tool calling loop, kind of what you would expect. And then you can flip on code equal to true. It'll become a code mode agent and actually just automatically run the code execution inside of a Monty sandbox. So it makes it really, really easy. We'll see this in action. But you can also use other frameworks. So I have other examples of like LangGraph and everything like that. So if you select what you're seeing today, but you want to use it, use a different framework to do a different pattern, but you still want to run it in Flight and stuff like that, you can. Just noting, we're going to use the built-in kind of Flight agent pattern today. So again, talking about Flight or Union AI. So Union's built on top of Flight. Flight is our open source that we're the core maintainers of. So it runs in your cloud or on-prem. It's not like a service product here. So a lot of companies like in healthcare or places where they have like massive clouds where they need a lot of compute, they use Flight or Union to manage their orchestration piece and runtime. So you can kind of see a code example here of what defining a task environment looks like. And this is the core of Flight, where you define this all in Python. You say what image you want your task to run with. So instead of writing Docker files, you can just do this all in Python in your Python project. You can pass it requirements.txt. It can read from a UV script. You can add in manual pip install here. There's a whole bunch of different ways to define it. You can add like apt-get and other terminal commands that set up your container exactly as you want it. Again, all just in this Python SDK though. And then you can declare the exact compute that you want this to run in. So here it's saying like I want 4 CPUs, 24 gigabytes memory, and 1 GPU. And you can set this to specific types of GPUs if you have more than one type in your cluster, like you want an A100, a T4, etc. And then you can see here's another environment down here, very similar, just shows with pip packages here. And then you have no GPU and kind of lower CPU requirements. So pretty common when I'm orchestrating like deep learning tasks with something like grPO or whatever for fine tuning. I have my data download, my model download, some other pre-processing tasks all running on a lighter weight CPU. And then I need a heavier weight task with like GPUs, more compute. That's like my training evaluation type of task. So I'm not wasting or hogging a GPU when I don't need one. You just define this again in this Python SDK. And then for your tasks, you basically write pure Python in V2, which is what we're on now. There's not even any DSL. You write pure Python. You just add a task decorator on top of it. And then you can pass in parameters like, do you want caching on that task? Do you want reports, etc. Just on top of Python or async Python as you normally would. And then this gives you kind of like we were seeing, like here's an example of a whole bunch of runs that fanned out that can run in parallel. So each one of these, again, if I had defined that container with the amount of CPUs, it spins up a container with that, and then it runs inside of this container on that compute. And again, everything's version snapshot. So you get all this observability stuff out of the box and even embedded reports here. So you can come back and actually see, like I use reports all the time for training, for example. So if you are fine tuning something, you can go back and have an embedded report and do your experimentation management this way, which is also really cool for agents, which is what we're doing today as well. So you can actually have agents like give you an output in a report this way, or we'll see it will come back in a chat interface. Anything else that I mentioned? So everything's snapshot version. So you get whole lineage on your data, agent run, waiting for its typing. it's super flexible. There's a pretty big plugin ecosystem, but it runs again in Python. So most stuff will automatically kind of work anyway. Plugins make it a little bit easier sometimes, or it gives you like an extra button directly in the UI. Scalable, so it's built on top of Kubernetes. So again, if you are going to build an agent on this today, one of the really big things that you would get out of this is being able to scale up to like massive amounts. So if you're running like, I don't know, thousands of research agents at the same time, and you need to scale out a whole bunch of parallel compute that all runs at one time, and then surfaces those outputs into some memory. You can do all that very easily. So again, hopefully you'll see this is really the core of it. We'll see a little bit more, but really, really simple to use. Python SDK makes it easy for you and for your agents to write. And so what's that? So it's like Docker without Docker. So that is part of it. And then you do the orchestration piece and then all those other things that we had talked about. And the question about, does it run on WSL2? It should. I actually haven't tested it lately on there. But I should test it out, especially for DevBox. So if you want to right now, like I was mentioning, you could go set up this open source DevBox and then get a similar UI to like what you see here. Actually, I have a UI open, I think. It's actually running my DGX Spark here. I was doing a video workflows. So sorry, little bit of a tangent. We'll go back into the agents here in a second. But just to show you, this is the open source. These are all the steps I ran. I didn't do a lot of parallel compute because this is just on one GPU. So these are running serial here. But then I have a report here with all my AI generated videos kind of embedded in here. So you can run all this really easily locally on something. I haven't done the WSL2 with the latest version of DevBox, but it should work. So if you try it out, let me know. And then I actually will go try that soon myself. All right. Are people ready to go through some code? Do people feel like they have an idea of what a code mode agent is, even though we haven't run anything yet? So I shared that link again. I was doing this so you could run it in Colab. And I was making changes, like actually making the collab because the cluster thing wasn't working this morning. I ran through it, so hopefully it goes smoothly. There might be some untested parts, so we'll see what happens. I know the Gradio part at the end could be a little weird. Gradio is always kind of a little bit weird if you're trying to run it inside Colab. So it might not render the charts, but that's okay. We'll get most of the other workshop stuff here. So what I'm probably going to do is maybe go through this Colab with you with like some of the commands, the setup, but then I might go over and just in my VS Code, either pull up the code here potentially, and also just run some commands so we can also look at what they look like, I guess, locally and what they look like on the cluster, if that makes sense. So for this, what you can do is also just run a save a copy and drive. So if you do want to make any edits to this, you can. You don't have to do that. You can just directly run in there, but I do like sometimes following along and making my own copy. Then you want to run this first code cell. Actually, I'll do it for my copy, so that way I won't have anything pre-run. So run this first code cell. This is just going to do a little bit of setup for us in Colab. It's going to download that workshop repo that I shared. It's going to change directory to the code mode analysis. It's going to start installing these requirements.txt. And then it's going to also install something called keyrings. We only need this for like Colab or headless environments where you don't already have a keyring installed. This just allows us, actually, since you're running it locally, you don't need this. But if you were running this and deploying it to the Union cluster on calls, you would only have to auth once versus all the time. And that's the keyring part. And then we're setting the output to be, they call it dumb for the output that gets rendered here. I had some issues sometimes with Colab trying to be fancy with the rendering their outputs, and it makes stuff look worse. So we just getting a more basic output here. So we're already installed. And then if you want to follow along too, I have this to run on Anthropic. I didn't test just swapping this over. It does just use the OpenAI chat completion. So it might work if you just use an OpenAI key. But I did not test that. So I'm using Anthropic. You'll need your own Anthropic key if you want to run this. Again, normally I'd give you a cluster with one in it. It just didn't work out this morning. So I'm going to run this. It's going to ask for an input. And let me not share my key real quick. Grab my key because I restarted this runtime. Oops. All right. And go back to the project. All right. So I'm going to paste this in, and that should be good to go. Again, if you were running this on a cluster here, not just locally, like we're going to do in the notebook today, you could just set up this config, run flight create config. This will create something that looks like this. So you're just saying what endpoint do you want to point this to. So if you run this locally, it'll be like your local host. Union has something called remote image builder. So it'll build the Docker images actually remotely in the cloud for you, which is really nice if you're on airplanes or something and you don't want to pull down heavy images over a very weak Wi-Fi. This is really useful. If you're running this on flight, it'll build locally and then push it up for you. You have like domains and orgs that you can push to, and then like projects as well. So we'll skip that for today. And then you'll see we have this first command is flight run local step 0 download. This actually doesn't use the API key either. So if you didn't set it, you can run this. And with this local flag with flight, it's really convenient. You can just toggle local by passing this local flag when you run workflows. So if you want to run things out and like run a larger job on your cloud compute, you would remove this. But if you want to do quick debugging and iteration locally, like maybe even when you run local, you use a smaller data set or smaller training parameters or something like that. But it's really, really nice for building out your pipeline locally, debugging it very quickly without having to spin up compute and then look at logs somewhere else. So really easy to switch back and forth between local and remote runs. Another cool thing for agents is we do have a terminal user interface too. So if you want to debug agents locally before you do a larger run, this makes it really easy as well. So we can see this ran. And if I run this next code cell, I should have just probably already had this rendered. This actually reads in the files that are relevant to this run step. So this is where you can look at the code yourself here for exactly what we ran. So we ran step 0 download data, and this is just going to download some data set here. If you want to look at the code for everything that you run, it's going to be that layout. And I'm going to run over to mine real quick and run this without the local flag. So I'll run it there with you, and then we'll go over here and see what this looks like in the cluster. So I'm just removing that local flag, and then I can click on this. I'll open up that task, and we'll see that actually caching is enabled when we look at the code here. So when I ran this, it didn't really do anything. It just rendered all these things because I've already run this before. And then I said cache equal to true. So anytime you run a workflow that uses a task with caching on it, it is going to pull the cache and not rerun that step. So really useful if you're doing something like downloading data sets or models. Makes it really easy for that. So here, if I look at the code, you can see that we have this task decorator. Yep. Let me make sure I have the right one rendered in here too. Yeah, so we had this task decorator, and this just is downloading the data set for every month. And the reason why I actually did this, if I was actually doing this production, I would just set this up probably as a database to query. But because this is like an external database that you can query, but if you fan out a whole bunch of agents like we're going to do later, it'll yell at you kind of because it will rate limit you. And so what I did was just pull this down into cache so that when we run a query, we're just going to run it on our cache instead of like the hosted database. But in production, I would actually probably have this just as a hosted database at a URL and then query that directly. So a little bit of a, hopefully not too weird of a thing, but what we're doing here instead of kind of a normal production way, just to keep it all kind of consolidated in the workshop flow. All right, so then the next step is we can run the sandbox, so it doesn't use the LLM yet. So you can run this, and you can look at the code once it runs. And again, I'll run this in my terminal too. Did I not copy? And this is where the code starts getting a little bit more interesting, where we use the Monty sandbox built in from Flight. So my run kicked off here. I'll open this up, and it's going to load in the month. It's going to load in the other month. And we can click into these and see what the exact query is. So you get the input and output logged in the UI again here. So we can see the input is this month, and it's calling a function. We can look at it in a second, but this is the output that it gets returned for loading that month. And then there's a % change function called too. And if we look at the code for this step 0, step 1, we are calling a couple tasks here. So we have that load month, that's a task, and then it's calling the tools that we've created. Oh, sorry, this one. Oh yeah, and then it's calling sandbox orchestrator, which is running the tools within the sandbox, basically the Monty sandbox here. So super simple. This isn't an agent yet, right? Just kind of showing you how you can call tools within the sandbox here. So this is kind of building a pipeline that runs inside that built-in Monty sandbox orchestrator that's in Flight. And we had just defined our kind of % change and load up here. And then we manually define our pipeline here. But this is kind of what an agent is going to build and then run this within that orchestrator. And so if you go to step 2 and run this one, going to go back to Colab. Also, real quick, I don't know if people are following along, but so like last week when I had the hiccup of not being able to add people to cluster, and I didn't have a Colab for people to run along that had like the local commands like this. Do you think having kind of running these things locally and still getting results is cool and more interesting if you aren't connected to a cluster? And we'll see a little bit later, but you still get things like caching, like we'd mentioned. So when we downloaded that data set, it got cached. You get retries as well. So you get like durability pieces that are built in. It just might not be super relevant without the UI surfacing them to you. And you get reports. So we have that thing built into Flight that renders reports that you kind of saw in the UI. But they actually create these HTML files that you can pull down locally, or they get generated and saved locally, and you can still view them. So you get really nice reports that are rendered in here. And we're actually going to do, again, most of the stuff here just locally. Is that still interesting to people if you don't have access to a cluster or you didn't set up Flight dev box? I'm kind of curious, like what you feel about the vibe of running, I guess, running a workshop in this flow too, of like seeing it locally. You get to run all this stuff. Maybe you just don't have, the scaling part. Is that still interesting to people? Because last time I asked people, it kind of seemed like yes for some of the stuff. Like Google Colab also has built-in GPUs that you could use. So if we do something on like fine tuning and GRPO, and you couldn't get a cluster with GPUs, or you don't have a GPU home for DevBox to run in, you could still run it in Colab and kind of learn all the practices and stuff. I don't know. Is that still interesting to people? Trent said, yes, hearing the local approach with trade-offs is helpful. Awesome. Yeah. So I think, I forget, your name looks familiar. I think you might have been at the last workshop. But yeah, I think from what people were saying last time, I think it's cool. You still get to run through all the code and even get all the results. You just don't get like a little part of it, but you still, if you're here more for the theory too, which is like usually when I make workshops, like I want to show you what I think the best ways are with Flight and stuff, but all the, and we're still using a lot of the Flight stuff, but the kind of the practice and theory, you still get kind of a little bit more hands-on with, I guess, if you're running the code and you get to see those results. So I don't know, hopefully that's still interesting. I want to try it out. So yeah, I just wanted to get a pulse on if you still like this kind of format of being able to run these things, go through the code and get results on it. So for the step 2, what we're doing is, this isn't quite like a full-on agent. It's running in the same sandbox, except for the program now arrives as a string. So this, you can have like the LM actually generate this, but it's not doing the full kind of agentic loop yet, where it can like self-fix and stuff like that. So we'll see. Yeah, like this. Well, you kind of define a little bit of a loop. We're not building like we're not running the built-in kind of agent in code mode yet. So we'll go look at the code here in a second. again, you can run the next code cell and you'll actually be able to view the code files here. So we're looking at the, it's pretty long because I'll handwritten stuff, the step 2, and then the tools.py. So if you go to step 2, generated code, we can see that, we zoom in, realize that might be a little small. Maybe that's a little too big now, especially with my terminal. Let's get rid of this. Well, I guess I need that to navigate a little bit. So this one, the model writes the code and the sandbox runs it. So we're starting to use our LM. So we're kind of, again, building our agent, our code node agent here in pieces. So we're importing flight sandbox, and we have some sandbox rules that we're going to pass in. We define this in our lm.py. We'll go look at that in a second. We have a function where it's going to pull in data from our tool catalog. So pretty similar if you've built agents before, used agents, it's pretty common. You're going to pull in like a doc stream and a tool name, and you're going to infer information about it that way. And then we have our generate code function. So this just asks the model for the program and returns the code inside of the fence block. And this is what we're going to pass into then run inside of the sandbox. We have our analyze, which report is equal to true. That's how we can display that report directly in the UI, like we see here. Again, that report, if when you run this locally, is also stored locally, and then you can just pull it out and render it this way or look at it HTML. And then this is going to basically be a for loop. So it's going to, we give it a max retries. So it's going to try to, like sometimes it executes code and it's wrong inside of the sandbox, and it's totally fine because it's in a sandbox. It doesn't like blow anything up, but it'll come back as an error, and it'll try to execute in the sandbox. If it doesn't work, it's going to do it again until it hits max retries. So you usually want to add some sort of max retries to your loop. Otherwise, your agent might be stuck in it forever. So we can pass in this, and then when it errors a certain amount of times, even if it doesn't get the answer, it's going to stop. And then we can see that we're passing in that code and the tools and whatever other inputs that we want into our flight sandbox, which again is that Monty sandbox piece here. And then so this is kind of hand building kind of that agentic loop a little bit, where it's going to try running this code. If it doesn't, it's going to retry it again, and the Claude is just coming up with a plan for it. And then in step 3, we're actually going to build out and use the flight agent pattern. Just look at here again. Go ahead and scroll down, and you can run this. We already did view file. Now you could run this locally, and this one is now we're building the agent and the fan out if you're on the cluster. So we're using, we'll look at the code here, but we're going to import the flight agent. So I think I shared the docs too earlier, but you can pass in the parameter code mode equal true. So when you do this, it's now going to flip it where it's going to run inside of the Monty sandbox by default. And if you don't have that, then it's going to run like a normal agent would, coming up with kind of the not running a sandbox and just generating tokens, right? So it's going to run the loop inside of the sandbox, and the query that we pass is now a task. So when the model answers basically a 12-month question, which we're going to see, we're also going to use this built-in thing called flight map. So you could also do this with like async IO, where you're doing some sort of fan out. You want to run things in parallel. We have something called flight map. And so it's going to take in a query, look at something for 12 months, and then spin out like a whole bunch of, or at least 12 parallel containers running at the same time, and then give us the answer from there. So when we run this locally, it's not doing that. It's running in sequence. And I think there might even be an output that says like, oh, it's running in sequence right now. But if I run this without the local flag on my thing, we'll see it fan out, and mine already finished running here. You can see the report is rendered in. So we asked it, rank the boroughs by tip rate and show how much it moved through 2024. So it's going to be probably looking at the 12 months and hopefully giving us a chart, which you can see it did. And these are tip rates from different neighborhoods, basically inside of New York area, which I think in the data set even says, there's some stuff around here where it's not always true because tips are often cached in certain areas. And so it's not logged in the data set. So just keep in mind, this data set can also be wrong, but this is just what's in the data that we're rendering. So let me go back and run this. Again, I'll remove the local flag here. And then this, I think, should do some fan out that we'll actually see happening, which is kind of fun to see. So it's running the analyze, and then it's going to come up with a plan, like Cloud is coming up with a plan. I should probably print that out here. I don't think I printed out into the logs, but I should probably have it coming up like with what it's thinking and the plan. You can see it started doing these queries, and then it's doing these in parallel. And then it's looking at, I think in the code I actually say it can do 4 at a time. But you could have this fan out to like, whatever that number is, that as long as you have enough compute on your cluster to handle, you can do all those things in parallel. So we can see it spun up a whole bunch of stuff in parallel here. Also, just quickly note, so you could do all this in the open source, and you can see how fast these containers are spinning up here. They're not even reusable containers. They're spinning up and then running whatever we asked it to run, like the queries in this case. In Union, we actually have something called reusable containers. So you can just spin up a container and then use that container across all these different tasks. And I actually should do that. Would be even faster here. But this was like just spinning up containers that were already down, not even reusable ones. And you can see how fast it went inside Union. So we could even speed this up more with reusable containers. So we can see it returned a query. So again, telling us a little bit about what's in the data set here and giving us a chart, just like we saw in the local one, but it was able to fan out these things in parallel. So again, if you're doing something like, we have some customers that use Union and do like, massive research type agents. And so you can imagine having to spin up like a ton of compute for running like thousands of things at once. A lot of like a local setup's not going to be able to do that very fast. Or unless you're super beefy computer, I guess, and you can handle all the concurrency. But typically with stuff like that, again, you want something like Kubernetes or Flight to orchestrate that thing where you spin up all that compute, run all the stuff in parallel, pass that data back, and then get an answer, like in this case. But again, our use case is a little bit smaller today, but you can imagine why you might want this kind of massive scale here. Oh, and if we go back and look at the code, sorry, this was step 4, or no, sorry, 3. If we go look at the code, some probably major things to call out would be, say that, well, this is one with the agent. So we're starting with the task. This is the analyze task. Where's the actual agent part? Because I know I put that in. So I build agent. Build agent comes from this analysis.py, I believe. And you see in that file, we said build agent, and then we passed in a parameter. It said code mode equal to true. So this is actually us where we define the actual agent piece from the flight agent. So like we imported from flight.ai agents, import agent, and then this allows us to just call this, and it'll run that loop that I kind of showed you in the doc before with like the tool calling stuff. All that stuff automatically happens now. Again, pretty similar if you use other frameworks that have like a pre-built agent. So here we're giving a name, and then name, and then we're saying code if code mode is passed in. Otherwise, it's going to be sequential for the name, and then we're saying instructions that gets passed in from. I don't think we defined it. Do we define it in this one? Yeah. So you are a data analyst for NYC Commission. Here's the tool descriptions that go in. These are the available months. So we also inside of the dataset.py, we had a little bit of predefined dataset columns that get passed in here because the agent needs to know the dataset or be able to query the dataset basically in order to write queries. And then you can just see there's more examples and like telling it how to do analysis. And then you also pass in some sandbox rules. So like what's available in Monty, what you can and cannot actually do. So it understands it's in a sandbox and won't try to do anything that it can't do within there, at least supposedly. We'll see sometimes it might anyway, but then it'll just fail. So we have our build agent, initializing it with our Claude model that we created with the API key, but you could use different models in flight too, because you can use GPUs to orchestrate your compute. You could actually use your own like fine-tune LLM here instead of one of the APIs like we're using today. Pass in our tools. Here we're saying code mode yes or no, and then the max turns that we pass in. So again, if it by default it's 6, and then you can overwrite this, but then it'll just stop running and won't get stuck in the infinite loop. And you can see that the last one, we had a lot of codes because they kind of hand wrote a little bit of this loop. In this case, it's super, super short, just using the built-in flight agents here. And that's the one that I ran that did all this fetching in parallel here. All right, now on to this one. So this is that measuring step. If you were here at the beginning, I know I see people join and then leave. If you're here at the beginning, we have that kind of compare one. So why write the code mode agent? Again, let's run this kind of comparing and see what happens. We'll run an agent both in code mode and one in the normal sequential mode. So if you go back to 4, basically this is calling the agent just like in step 3, but then we're also initializing an agent that that is just in sequential turns. And then we'll get a report. So a lot of times, like all this code is the report. So it looks like a lot of code, but it's just kind of HTML. So those reports can be like HTML or Markdown, and they'll get rendered nicely inside the UI like we saw. So let's take a little bit to run, and you might see some errors here. That's actually just errors because one of the LLMs or one of the agents is trying to call stuff that that doesn't work. So like it's trying to query the database that we have cached, and it's getting an error, but it's kind of self-correcting because the error goes back to the agent. So when it's done, we'll have that report rendered there. And I already have this rendered from this one that I ran. So you can see this is all the runs it did. You can see I actually had a failed task here. That's probably because the input to it was wrong. So yeah, it says run full program select or whatever instead of actually passing in a SQL string. So that failed. And then you can see all these other ones actually were success. And you can, again, click in and see what these queries were. So this looks like actual SQL. That's why I succeeded, right? And then in this case, I got an empty output. But some of these should have actual data returned, or if they were cached already, because if I did this, I'm having caching happen automatically. So if it had the exact same query, same data set passed in, it's going to cache a result, and that's going to live in blob storage, and then it'll pull that in instead of rerunning it. But we can see that for this one, we had... and for those reports, you can click this agent tab and actually see all the steps the agent did too. In Colab, you should have that as well. So for some reason, I have the chart didn't render here in the report. I think there's supposed to be a chart here, but it didn't work. But that's probably just a bug on my end, or just the agent wrote a bad chart here. But we'll see again for trying to get the same results for a question. The model turn for the sequential agent, it did 11 calls basically. It did a query, like all these actually, I think, right? It's like it's doing a query, it's trying to pull some data, and then it needs to do another step after that, and then another step after that. And in my case, they're already cached here, I think, so it went pretty fast. But then you can see the code mode agent can run all these in not only parallel, like the sequential agent could do some steps in parallel if you actually have like a better planner set up for it, but often won't be able to do all those steps. And then it needs to look at the data and take a turn. So in this case, it basically did them one at a time. So it did a lot more steps than the code mode agent, where it could just run everything and get the results with its code querying. In our case, calling SQL to that database. And you can see the input token is quite a bit less for the code mode as well. And then the output token is also quite a bit less. So instead of writing kind of next steps here and understanding what was returned from a query in our case, again, the Python code can just kind of do that all at once, and it doesn't have to do that. You can see the total token usage is quite a bit less. So when code mode comes in, you're trying to make things like more efficient. It can obviously be, it can have a huge impact on your token usage. It's not always probably the right case. Like if you just have one tool call, you don't have complex workflows that your LM is writing, then you don't really need a code mode one. But again, code mode just potentially is a way that if you are doing things where you're writing a ton of tasks and are stringing together a whole bunch of orchestration logic together, orchestration logic works great inside code. So one, it might fail less. Two, a huge amount of token saving potentially for you, and time sometimes too. Like if, again, writing everything at once, querying it, the latency can be quite a bit less than doing those tokens and generating tokens, getting a response, generating more tokens, thinking about it, generating another tool. And again, in our case, we just use a sequential agent. You can do, like I'd mentioned several times, different types of agents. Like you could have a planner agent where to come up with a plan and then run things in parallel, kind of like we saw here. Our sequential agent didn't do, but it can come up with a plan, run things in parallel, but it can only run so many things in parallel. Like it can run parallel, get the data, and then run a next step if it relies on that data, right? Whereas the code mode can actually build out more complex orchestration piece. And here, it actually said the table isn't cooperating, but the metric chart already carried the finding. So I think it was our sequential one was having a little bit of issue with the querying, which I guess might be from these errors here too. Again, you can click and see the code that the code mode agent wrote. So instead of, again, coming up with all this, if you've seen agent stuff, you've probably seen all the inputs and outputs. So instead, you're getting code like this and hopefully good results from it. And again, you can click in and see kind of all these agent steps as well. And the Colab should have that. Okay, yeah, it did load. It just, I think it has that space for like a chart. If you scroll up, if you scroll up in the chart, you should have this tab. And you can see these are the queries that the agent was writing. And this is the sequential one. Oh yeah, it's the one getting the errors. And then this is the code mode one. So these are all the steps it took: getting data, thinking about that data. You can see it's getting some errors too. The code mode one in our case worked really good for our setup here. So way faster and more efficient. And then the step 5 here doesn't work super great for running directly in Colab here. I was just trying to get it to work this morning. This kind of runs a Colab where you can run queries to your agent then. Runs a Gradio app inside Colab. Kind of has an issue in here, like won't render charts correctly. So I'm going to show you. I also made an app that, again, I can deploy to my cluster here. I can run Python step 5 chat app and deploy. And inside of here, you can see that you can still go look at this code and everything. But here we create an agent app environment. So this is kind of a pre-built chat template that's in flight as well. You could also do Gradio or Streamlit or any other HTML hosted inside of an app. It doesn't have to be the pre-built one. Then we pass it some setup parameters. But the interesting thing is that, again, you can just define your like scaling directly in this Python SDK, which is really nice, instead of messing with any other like ways to do this, like in Kubernetes. Same with your compute and Docker files, just like we did for all the tasks. But you can now do this for a hosted model or an application. So you say how much compute you want. You can say how much scaling. So it was from 1 to 3, but I'm going to set it from 0 to 1 now. So after this workshop, after I haven't used it in 30 minutes, it's going to scale down and I don't have to pay for any of that compute. You can also add scaling metrics, like if a certain amount of users come to us, that's when you scale to the next replica. So really easy to use API to handle, again, your model deployment or app deployment as well. And there's built-in things like VLM and SGLang. So if you're actually deploying a LM or something like that, or VLM to a flight cluster, really easy as well. And it's just fast API as well. So if you just want to host a any type of model or whatever in there. So let's query this. It's going to say, how do JFK and LaGuardia Airport pickups compare on trip distance, fare, and tip rate across 2024? So again, asking across a whole year. If I go look at my flight runs again, it's actually now generating this new answer. And this is going to start doing the fan out queries. And like I mentioned, I should use reusable containers here. This would be way faster. You can see it's already pretty fast just spinning up the containers, even without using reusable containers. And again, I could click in and see which one of these queries or which one each one is doing. This was the input. And again, it got, I guess, an empty one here. Sometimes it gets where it's seen if there's data in there, and sometimes there isn't. And then when it's done analyzing, it'll render the report here, but it should also come back directly in our chat. Boom. So we have our two color legends here, JFK and LaGuardia. And so what was the question was how do airport pickups compare on trip distance, fare, and tip rate over time? So it created these 3D charts for all those questions. So you have tip rate is higher, LaGuardia is way higher, or yeah, quite a bit higher. Average fare by airport, JFK is higher, so people are probably taking longer trips to get to JFK. These are both airports in New York, by the way, if you didn't know. And then the average distance to airport. So again, JFK is a little bit farther, which I mean would make sense that fare is higher than as well. That's probably the biggest reason why is more distance. So again, was able to write SQL queries, fan out multiple searches at the same time, generate a report, and then bring that in here, all with a code mode agent. That's kind of all I have designed to show for you today. Was it interesting? Did you learn something new? Are you going to build a code mode agent now? Have you built a code mode agent before? Oh, maybe I didn't. Oh, I just might pass the, in this case, I might pass the report just as an output, not render it in there. But yeah, that's probably why. Yeah, did people run the collab at all too? I have a few minutes to hang out for questions. If you have questions later, again, you can join the Slack channel and ask them there. Also, again, I'll shout out the flight dev boxes. Really fun to run. So you need Docker installed, and then just pip install flight, and then you get, again, cool interface, just like we were seeing today. Obviously, scaling out and stuff, or what your compute is, depends on what you're running this on. Oh yeah, so I'm actually going to talk more about this project too. So if you do happen to be interested in video generation, let me pull up the event for that. Oh. Any other questions too? I'll be hanging out for a little bit, but I will have to wrap this up pretty soon. But yeah, if you do want to, this is more of a casual stream that I do often on Fridays, talking about kind of a project I work on at the side. So if you're just interested in, I don't know, talking about open source video generation in this case, so these are all open source models. If you think that's interesting, you can join the stream on Friday. But again, this is all in the flight dev box here. All these blacksmiths, I'm sure if I prompted to put gloves on them or something, it would, but it didn't by default. So all their hands are really going to hurt in the morning, I think. No other questions? I still see people here, but I haven't seen anything in the chat. I'll still hang out for another couple minutes before I end this stream. So if you do have any questions, let me know. Still see people hanging out, but no questions. All right. Well, I'll wrap up the stream. If you do have questions, I think you know where to find me. Again, either on Slack, like I just shared, or also on LinkedIn if you want. So feel free to message me there as well. Thank you, everyone. Thank you for the people, especially spoken chat, and let me know, when I had questions about how did things work. Always great to have you here. Thanks for everyone else for joining as well. And hopefully I'll talk to some of you all next time.